Let us see the first example that we have. As you see, in the binary section, we have the numbers whose order is less than 2. And then by this method, we can convert the numbers. See, the first example is something like this, 1101.101. Uh, there is some questions like this that we have the two type. One is that the real type and real part of our numbers, and another one is some part which is come after the point. Maybe you have the experience to solve this and convert these numbers, I mean the real part or integer part of our numbers, and conversion of that. Maybe you are very expert for that because it's very simple. You, in this part, you should just divide the integer part by the base that we want to know. I mean the two which is here I written, we call this as the base. Okay. Let us see. I think it's better that all of us now have one piece of paper and solve with me. Okay. Do you have any paper with you? Okay. First, I want that you do this part and then this part. Means that for the any numbers that we want to convert into the any base, not just two, which is I show here as the example. Any base that we have, the integer part should be divided by the base number. See, first we will start from 1101. 1101, if we want to divide it, we can do the sum sequence of division to that, or another method is that we can give the value to each position of numbers. Maybe you see the lectures number 1 as I showed you. I don't know the real name for this method. In my concept, it's something like GPS. You know what is GPS? GPS is the location of any point in the world. The clear concept that personally I have about this conversion is something like that. Each number has any GPS or any location in the base. Let us see what I mean. I mean that suppose the first number here, if you see this number is 1, how many numbers we have after that? 3 numbers. Then it can be 1 multiplied by the base and with the power of how many numbers remain in front. Okay. Another one, suppose see this number. This number, how many numbers is in front? 2. We can have base power by 2. How many numbers are after this? 1. Okay, then we have the base with the power of 1. And for the last number that we have, you can see that there is no number for that. Then we have 2 multiplied by 0. Okay. Okay. Then what we have here, we have one critical situation here that this is the point. Okay. This is my point. For my point, I can have now minus. Okay. Then 1 multiplied by 2 power minus 1. And then next one, 0. 0 is like that. See, 2 power by 2 minus 2. And then the next one, 1 is power by 2. And then simply I can calculate these. And you can see after summation, we have this. Okay. Is it clear for all of you? Can you give me feedback by the text? Just text. Okay, Fahim, good. Okay, you see that in it's very simple, very simple. What I mean that just if you see the location of the numbers and how many numbers we have after that, it's become with the positive one. Means that through the integer part. And after the flute means that for the flute parts, we are going for the minus. Means that how many numbers after the flute? 1, then it's become minus. How many numbers after flute? 2, minus 2. How many numbers after flute? 3. It's become minus 3. It's clear, yes? Give me in text. Let us see the next example. The next example also, it's very simple. Can you see we have two parts? One is that integer one, another one is the float part. Same rule we have. I mean that for the integer part, how many numbers we have and how many numbers we have for the float part. Okay, we will start. If I want to start from this number, this 1, okay, how many numbers I have after that? 1, 2, 3, 4. 1, 2, 3, 4. Then it's become 1 multiplied by 2. See, 2 power by 4, because 4 numbers are here. And then next is number is 0. Then how many numbers after that? 3. Okay. Then 1, as you see, how many numbers we have? 2. And last 0. See last 0. How many numbers? We don't have any numbers for that. Okay, then it's become 2 power 2. Same thing will happen for the flute part. For the flute part, if you see, we can count that how many numbers we have after the flutes. The first number is 1. Okay, then it should be 2 power by minus 1. Yes. And second one is 0, which should be power by 2 minus 2. Next one, 2 power by minus 3. Next one, 1, 2 power by minus 4. Simply we will calculate, and then our number in the decimal base is this number. Okay, is it clear? Wait, let's go for next example. Now what I want, please have one piece of paper in front of yourself. Next one is very simple. Next one is simple because now you have the real part, and inside of the real part, it's very simple to calculate. How you will do that? Very simple. We have one number 10011. 10011. If I want to convert it to the decimal part, it's simple. First, I will select the number. I mean, number 1, this one. And then I will count how many numbers I have. I have 4 numbers. Then it's become 1 multiply 2 power by 4. Okay, next is 0. 0 multiply 2 power 3. Next one, next 0. 0, 2 multiply, how many number I have? 2. Okay, 2 power by 2. Next one, 1 multiply 2 power 1, and next one is 1 multiply, yes, 2, 0. Simply I can calculate this, and then we will see that it's equal to 19 into the decimal base. Okay, now let us do it in another way. What we have done now, we just find that from binary to decimal, how should be the numbers. Now from decimal to binary, how we should convert the number. Okay, it's simple, very simple. The simplicity is like this. I will take my number and I will see the base. Suppose my number is 26. My base is binary, means 2. Then I should divide it by 2. I will divide by 2. How many times I should divide? It's no end. You can divide by the time and so many times even. But sometimes people say that 5, 6, 7, something like that they can do. Let us do it. 26 divided by 2, it's become 13, 1, 3, and reminder is 0. I will keep this reminder, okay? And then again, see this number, 13, divided by 2. Divided by 2, it's become 6. 6 by 2 is 12. 1 will remain. I will take this, okay? Another one is 6. 6 will divide by 2. It's become 3. How much is remainder? 0. Okay. 1. 1. 1 divided by 2. Again. 1 and then again 0 divided by 2. You will see the number. Okay. Then we will start to write from here to up. See. Here to up. Let us see the next one. Next one is also same, 63. We will do the process, same process. And then the reminder is 1, 1, 1, 1, 1, like this. We will start from the last one and going up. Okay. These are for the numbers who are in the integer form. If my number is in the float form, what should I do? It's also same. For the integer one, we have one process. For the float part, we have another process. Nice thing is that for the integer part, we have the division process, and for the float parts, we have the multiplication process. See, my float part, my integer part is 22. Then simply I will divide it by 2. It's become 11. Divide 11 by 2. It's become 5. Divide 5 by 2. It's become 2. Divide 2 by 2. It's become 1. 1 divided by 2. It's 0. And then remainder is that. Means these numbers or this part is my, it's related to my integer part. See this. This is my integer, which I will start from up, down to up. Last one, first one. I will written it here. This is my first. Okay. What about this part? What should I do? For this part, I should multiply it by 2. How? Like this. First, I will multiply 73.73 by 2. It's become 46. Okay. Then again, 46 multiplied by 2. It's become 92. 92 multiplied by 2. It's become 0.84. And 84 divided by 2. It's become 0.68. 68 multiplied by 2. It's become 36. Then from down to up, we can again write. Wait. For the float part, we will start from up to down. For the integer part, we will start from down to up. Okay, see. This is my first one here. Monshi question was good. 0.6, I want to go from octal to decimal. Octal to decimal. I tell you, think for the GPS method that I tell you, or on the other way, the method that we say that any number has its own value, its own location, its own system of value. What is the answer for this? It's very simple. First, you will take the 5. How many numbers you have after that? 3. Then it's going 5 multiplied by 8 power 3, 7. Next one is 7. Multiply 8 power by 1. Next, 2. 2. Multiply 8 power 0. For this one, we will go for minus. Let us see the answer. Okay, float part is also simple. 6, and it's one number after my point, means minus 1. See? Understand? Okay. Next one, suppose I want now do the reverse job. I want to convert from binary to octal. You know, decimal is our key. Binary to decimal, decimal to octal. We have even some way that we can do it directly to the octal, but we will do it in the next task that we will review. But I want that first you convert it to the decimal part, and then from decimal you convert it to the octal part. Okay, who can answer this? What is the relation between binary and octal? It's something like this: 2 rises by 3, it's equal to 8. Okay, it means that if I select 3 number from binary, okay, and if this number is remain, I will put the 0 for that, and then have again 3 batch. Each batch can give me the number, you know, and then convert it to the decimal. Okay, can you tell me 011 in decimal? 011 in decimal is like this: 1, 2, 4. Yes, based on our GPS system. 2 plus 1 is 3. Next one: 1, 2, 4. It's become 3. And next one is just 1, 0, 0. Okay, this is another way that it's something like shortcut. Instead of first convert this binary to the decimal and decimal to the octal, we can directly go from binary to octal. Okay, understand? Any problem? Okay, now you will see for this number we can select 4 number because we are going for hexadecimal. There 4 by 4 we can convert to the decimal, and then it's something like binary to the hexadecimal. Okay, let us do the next example. I want that you convert this number to the hexadecimal. To the hex also it can be with 4 by 4, but this number has little bit something that we should think for that. It's something like that. See, this is 1, 2, 4, and next one is 8. Let me change my pointer. Okay, if you can see, if I add 8 plus 4, it's become 12, and 12 plus 1, it's become 13. You know that I can count up to 9. The 10, it's become
Hey guys,
to
in this
8.
video I'm going to show you how you can install
10 become to 8, and then
18.04 on
this number, I
VirtualBox.
mean
So those of you who
13,
don't know
it's
what is
equal to
VirtualBox,
D.
VirtualBox
Same is for E as well as same is for 2. Then simply I can say my answer is 2ED into the 16. Any problem or any question? Okay, let us do the next example. Next example, now I want that we convert from hexadecimal to binary. What we should do? How we can convert this? It's also very simple. We know that we can convert each one by each one. A is equal to this. How I convert it? If you see 1, 2, 4, and 8. Then 8 plus 2 is 10. 10 is equal to A. Okay. Another one is 3. 3 is 1 and 2. See, it's equal to 3. C is 1, 2, 3, oh, sorry, 1, 2, 4, and 8. 8 plus 4 is 12, which is equal to C. And 1, 2, 4, 8. 8 plus 1 is 9. And another one, 1, 2, 4, 8. 8 plus 4 is 12. 12 plus 2 is 14, which is equal to E. Then simply I can say the answer is like that. Okay, what about if I have any question like this? 2A point A means that with the float number, how I can convert to the decimal? Very simple. I can say 2 multiply that. How many number is after, means that in front of that? 1. Then it's become this base power by 1. Another one is A. A is equal to 10. 10 multiplied by 16 power by 0. Okay. 8 multiplied by 16 minus how much? 1. Good. Okay. Now you will see if you do this calculation, it's become by 42.5 and it's into the 10. Okay, what about this one? If I want to convert base 5 to the decimal, it's also have the same GPS method as we tell you before. It's very simple. You can convert it in 2 way or by this way into the decimal. Okay. First of all, any question for these lectures? Give me feedback in text.